This is chapter 12.1 for question number 2. We are doing what we call as a one-way ANOVA. So listed below are time in seconds in triathlon record while riding a bike for 5 laps through each mile of 3 miles loop. So this guy is will be driving 3 miles loop here. 1 mile is doing here, second mile, and then third mile. So 3 times, 3 miles loop, he do it 5 times here. Use this 5% significant to test the claim that it takes the same time to write each of the mile. This one mile appears to have a hill. So in this case, since this question given us a table, so you have to convert this into notepad. So how do we convert this into notepad? In your notepad, you have to write down miles and time. You have to have 2. One is a categorical and one is quantitative. These are all time, which is quantitative, and then these are your miles. So M1 is mile 1 and then 195. And then if I want to go across and I say M1204, M1203, M1202, and M1201, and then now you go to mile 2, M2, that is 199,202. So you have to do all this, and then M3 will be the mile 3. So you have to do this in your notepad, and then you save it. This is how you got to do in this case if you got given us if the question given us a table in this case. Okay, so once you save this, so we will go for the requirement check. Population is normally met distribution. Again, we assume yes, this is robust or loose. The population is the same variance. Again, we assume yes, robust and loose. Simple random sample. This question did not say it is a simple random sample, so we cannot assume that yes. So in this case, it's no. Independent, yes, because if you go on to this in the same 3 miles 5 times, they are all going to be treated every single time here independent. Otherwise, it dependent in this case means that your second mile depends on your first mile, but as you guys know that when you go to bicycle, these are all totally independent. And it's one way is because we only have one factor in this case, that is the time in this case. Okay. So for the hypothesis testing, your H0 is mu1 M1 equals to mu M2 equals to mu M3. So that means that we want to see that if the mile 1, mile 2, mile 3, they're all having the same mean time in this case. And H1, or your alternative, is at least one of the mean is different from the other. So this will be a F distribution, sampling distribution, and in your results. So again, make sure you use A equals to read table, and then you choose the file, and this is the file name that we have on your R. So make sure that is all nicely tabbed and nicely aligned. And then X in this case is time, and Y in this case is mile. Don't forget, X has to be quantitative, Y is categorical. And then we do the ANOVA LMXY. So you will get yourself your degree of freedom in this case. Your numerator degree of freedom is 2. Your denominator degree of freedom is 12. Your test statistic is 27.249, and your p-value is close to 0, 3.453 times negative 10 to the power of negative 5. So it's very small in this case. So we got this, we find the critical value. So critical value is 1 minus alpha, which is in this case is 0.05. We use a 5% significant. 2 is your numerator, and 12 is your denominator degree of freedom. That will give us around 3.89. So this is your step 4 here. How do we calculate all your results? Step 5. Your p-value has to be less than alpha, so this in this case not has. This p-value is less than your alpha because 0 is less than alpha. We will reject the null hypothesis. Step 6, the conclusion is there is sufficient evidence to warrant rejection of the claim, and the claim say that the cyclist takes the cyclist takes the same time to write each of the miles. So so in this case, this is how it's kind of the same conclusion we did mostly in our hypothesis testing. And then this 1 mile appeared to have a hill. So in this case, your answer is yes. It appears that mile number 3 has a hill because the cyclist takes longer time to finish that 1 mile distance. So if you look at this, this mile 3, you find out that they take a bit longer time compared to mile 1 and mile 2. Like this one only take him like 190 some seconds. This one take him 214. So that means that mile 3 in this case seems like it has a hill in this case. So in this case, seems like mile 3 will be a hill in this case. So this is how we do this chapter 12.1 one-way ANOVA question 2. So it's not that difficult in this case. So make sure that you understand the main problem, student make mistake here is in your R, make sure you use A as a read table, and your X has to be quantitative and your Y has to be categorical. So, and then if you're given a table, make sure that you type this table like this in your notepad. Otherwise, you will get that wrong.